Alright, welcome to lesson 1. I'm Mr. Simons. In this lesson we're going to be looking at inverse functions, which is new, but the old stuff, your types of functions, straight line graphs, and then how to find the inverse of that. So we're starting with the basic easy graph you've been doing since grade 9. Right, so for grade 10, 11, and 12, we need to know our type of functions. We have a linear function, also called a straight line function, and it's governed by the equation y equal mx plus c, where m there is my gradient. So linear function here, this example, y equal 2x plus 5 is a gradient of 2. And there c is generally my y-intercept, so this graph would make contact where y equal to 5. Right, then we have quadratic functions or parabolas. Y equal ax squared plus bx plus c, that's the general formula. We take example yx squared plus 3x minus 4. The minus 4 there again is also by my y-intercept, so this graph should make contact by negative 4. The hyperbolic function, as you can see, so between the linear and the quadratic, you see x to the power 1, x to the power 2. We also have cubic functions, which I didn't put in here as yet because we're going to do it separate under calculus, which is x cubed. University, there's also quatic equations, quatic functions. Right, hyperbolic function, y equal a x plus p plus q. Right, a there decides the shape of the graph, a there decides shape of the graph. There p and q are both asymptotes. No? Yeah, q being horizontal, p being vertical. So as soon as x is a denominator, you should know we're working with the hyperbola. Exponential function, y equal a times b to the power x plus q. A there again, a with b together will decide the shape of the graph. P there's 3 and q there is asymptote, in this case a horizontal asymptote. So those are your basic types of functions you've done already. Right, notation wise, we mainly work with the first two. So in equation form, we simply have y equal to x plus 8. So we're looking at the relationship between y and x in functions. Function notation, instead of writing y, we write f of x equal 2 times x plus 8. So I hope you see the difference. This is a function of x as it relates to 2x plus 8. There's still old formats, mapping, which you'll most of the time don't appear in your textbooks, but yeah, I still explain it. So f is such that x tends to 2x plus 8. This here is the same as that, so all four of these equations are the same. And we have set notation where we say braces or curly brackets. X and y, my coordinates, tend to y equal 2x plus 8, close the braces. That's just basic function notation. Right, now straight line graphs. Say a general equation, y equal mx plus c, or fx equal mx plus c. So I either write it in function notation or as a general equation. Right, so m there is the gradient of the graph, and m we will always get equals the change in y over the change in x. When I say change in y, y2 minus y1, change in x, x2 minus x1. C there, as you can see, is referred to as the cutting point of the y-axis, or in short, the y-intercept. Right? We assume you remember domain. Set of all permissible values of x in a function is called a domain. In simple terms, that basically means that how many x values will the graph touch if I continue drawing it. Right? If you extend it on both sides, left and right, how far will it go before it can't go anymore? For range, set of all permissible values of y, function is called a range. So now we're looking at how high the graph is going up and how low it's going. So that's my range. Right? Gradient, in short, you should know positive gradient will always go basically from my third to my first quadrant. See that straight line drawn? And it's positive because you assume you know in a Cartesian plane, As I move to the right, I'm going to the positive x. As I'm moving up, I'm going to the positive y. So there my change in x is positive, my change in y is positive. Therefore, I will be left with a positive gradient. This is called the increasing function, meaning as the x values increases, the y values increase. Therefore, called the increasing function. Right, we also have a negative gradient, which generally we have from the second quadrant, or not second, from the fourth quadrant to the second quadrant. So as you can see, my change in x is negative, but my change in y is positive. Positive divided by negative will give me a negative gradient. And this is referred to as a decreasing function, meaning as my x values decreases, my y values increases, therefore decreasing function. Right? They must either both decrease, or increase for it to be a increasing function. Right? Now, domain for straight line, for any straight line graph, will always be x of element of real numbers, meaning I can touch all the x values if I just continue drawing the straight line on both sides. Range for straight line will also always be y element of real numbers, because it can go up to infinity and down to negative up to infinity. Right? Now, to obtain an inverse function, we will be reflecting it across the line where y equal to x. So whenever we use the word inverse function, find the inverse equation, etc., we're dealing with reflection about the line where y equal to x. So what this means is my x value will become my y value, and our y value will become our x value. So if I add the function of x, 3 and negative 5, then the inverse written as f to the power negative 1x. You see there, my y value became my x value negative 5, and my x value became my y value. Right, now as we look at the problems, we go further, we will be dealing a lot with this. This is what's new in grade 12 and must be tested in your grade 12 exam. Hope you understand. This is just basics. If you enjoyed the lesson, please like, share, and subscribe. Wish you nothing but the best. Right? Together we will succeed.